Hi, in today's video I would like to share with you a very nice problem of Russian Mathematical Olympiad edition 1983. Okay, here is the following information. Find all pairs x and y as integer numbers such that we have this equation x squared equal to y squared plus 2 times y plus number 13. Okay, in fact this is very nice problem, but it is full with tricks. This is normal for mathematical contest. You have to be wary and prepared for those tricks. Okay, so the hint that I'm trying to give to this problem, just you are going to factor out this equation and check the parity. Okay, now go ahead, pause this video if you would like to give it a try to this problem. When you are, come back to see the full solution. Okay, let's get into the solution now. Since we have x squared and y squared, we have to consider the negative solutions. Without loss of generality, we will have x y is a solution, and I will have minus x and minus y is a solution, and also I will have minus x and y is a solution, and I will have x and minus y is a solution as well. I'm going to write down this equation. I will get x squared equals y squared plus 2 times y plus 13. Okay, this one equals, I'm going to factor out this one as a form quadratic binomial. We'll get y plus 1 quinary square plus number 12. Okay, I'm going to bring this term to the left hand side of this equation. I will get x squared minus y plus 1 quinary square. I'm going to factor out this one. I will get x minus y minus 1 is multiplied by x plus y 1 plus 1 plus 1. So after factorization is giving me this one. So this one equals 12. I will have three possibilities. The first choice, I will get 1 is multiplied by 12. Second one is you get 3 is multiplied by 4. The last one, you get 2 is multiplied by 6. Okay, since I'm looking for the factorization pairs, I will have a 3 different equation system. So but I'm not going through this one. I'm going through the parity. I'm going to check the parity of this one. Since 12 is an even, that means the left hand side of this equation is an even as well. That means the whole term, whole product is an even. Okay, if this is even, it doesn't mean both terms are even. We don't know yet. It could be both terms are even, or at least one of those terms is odd. If it's odd, it will be even as well, because even is multiplied by odd is giving you always even. Okay, so we are going to create another equation where we can check our parity successfully. Okay, I'm going to bring down the same equation. We'll have x squared equals y squared plus 2 times y plus 13. Okay, so this one, the same equation is giving me x minus 1 quinary square. So if you distribute this one, is giving us, x squared, which is good, minus 2 times x, which we don't have. We have to add another 2x, plus number 1, which we don't have. I have to subtract number 1, minus 1. So we already know this one is this one, which is y plus 1 quinary square plus 12. I will get x minus 1 quinary square. By taking this term to the left hand side of this equation, I will get minus y plus 1 quinary square plus 2 times x. By bringing this minus 1 to the right hand side of this equation, I will get 13. Okay, now I'm going to simplify this one more. I will get x minus 1 minus y minus 1 is multiplied by x minus 1 plus 1 plus y plus 1 plus 2 times x equals 13. Okay, so I'm going to simplify this one more. I will get x minus y minus 2 is multiplied by x plus y. So number 1, it will be cancelled out because one is positive, the other one is negative, plus 2 times x equals 13. Now we are ready to check the parity. So this is odd, 13 is odd. That's mean the left hand side of this equation is odd as well. Since we know this is even, that's mean this is odd. This is odd. Since this is odd, that's mean both terms are odd. Okay? Because odd is multiplied by odd is always giving you odd. Since we know this is odd and this is odd, so I can know this one. What is this? So we know x minus y minus 2 is a odd. That's mean x minus y minus 1 is a even. X minus y minus 1 is a even. Let's put it here is a even. So on the other hand, we have this term x plus y is a odd. This one is a odd, implies x plus y plus 1 is a even. Okay, now we have this x plus y, this is even. That's mean both terms are having the same parity. Okay, they are both even. So since we know they are even, that's mean we are going to take the even choice, which has even. That's mean we take in this one, which is even. 2 is multiplied by 6. In addition, this term is a smaller than this term. That's mean this term is taking number 2 and this term is taking number 6. Okay, so I will have an equation. I will have x minus y minus 1 equals number 2. The second term, I will get x plus y plus 1 is taking number 6. Okay, now I have only one equation system. Instead to have 3 equation systems, I get only one by using the parity. Okay, now I'm going to solve for x and y by adding the first equation on the second equation. Y and number 1 will be cancelled out. I will be left with 2x equals 2 plus 6, which is 8. That's mean 2x equals 8 implies x equals 4. Okay, I'm going to replace x in either equation. I will get y equals 6 minus 1 minus x. 6 minus 1 is 5. 5 minus 4 is giving us 1. So I will have x equals 4 and y equals 1. But remember we have only positive solutions here, but we need the negative solution as well, because we have x squared here, y squared. So how to determine that? I'm going to clean up this board and looking for the negative solutions. We already found x equals to 4 and y equal to 1 as a first solution. Now we are ready to move on to going to find another solution. If you take a look carefully at this equation, I will have x squared. By bringing this term to the left hand side of this equation, I will get minus y plus 1 quaternary square equals 12. Okay, now we have x equals 4. I will get x squared equals 16. Here is a problem. When you take the square root here, we will have either solutions. We will have x equals 4 or x equals minus 4. Okay, because if you replace minus 4 into this expression, the result will be the same, because when you take the square of minus 4, is giving you always 16 here. So this means I will have two different solutions. Now we get a new solution, minus 4, 1. Okay, so on the other hand, same thing here. I got y equals number 1. I'm going to add number 1 on both sides. I will get y plus 1 equals 2. By raising number 2 as a power on both sides, I will get 4. Here is a problem. When you take the square root on both sides, we will get minus 2 or number 2. This is if 2y plus 1 is inferior or equal to 0. This is if y plus 1 is superior or equal to 0. I'm going to check with this one first. I have y plus 1 equals minus 2. That's mean I will have y equals minus 2 minus 1, which is minus 3. we'll have another choice, y plus 1 equals number 2, equivalent y. By taking number 1 to the other side, we'll get 2 minus 1, which is 1. So we'll have another 2 new solutions. I will get equals minus 4 and y equals minus 3. The second solution, I will get x equals 4 minus 3. Okay, this is 2 more solutions. Now I'm going to put all the solutions together. I will get the first solution was x equals 4, y equals 1. The second solution was x equals minus 4 and y equals 1. The third solution was x equals 4 and y equals minus 3. The last solution was x equals minus 4 and y equals minus 3. Okay, I have found all the solutions for this equation. I have done this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.